Everyone, my name is Vishal. Today I'm going to talk about one of the famous principle in our mechanics, Bernoulli's principle. So, this video will unveil the physics behind the simple shape that has revolutionized the engineering world to us. Our topic today is how aeroplanes generate lift. So, an airfoil produces a lift force when the fluid flows over the surface. Here we have the aeroplane's wing. This is the top surface of the wing. This is the bottom surface of the wing. And remember that the surface is curved from the top and from the bottom. So the particles on the upper surface should travel a greater distance than the particles on the lower surface, since both particles should reach at the end at the same time. So if I draw an airflow from the top of the wing and airflow from the bottom of the wing, they both should reach here on the same time. See, so our goal is that our both particle flowing from the top and bottom of the wing should reach here on the same time. On the other side, here we have that the upper surface particles should have more speed or velocity than the particles on the lower surface. This means that according to the Bernoulli's equation, there is more pressure at the top of the surface than the bottom. So here the particle will have higher speed because it has to pass the greater distance than the particle at the lower part of the wing, because it has to pass through the lace surface, which will create low pressure at the top of the wing and high pressure at the bottom of the wing. If we talk about, let's investigate this to any other surfaces. So according to the Bernoulli's law, if we apply airflow to any other surface, it should create the lift. Any other large surface. And now we will examine why this is the case. We will examine the physics behind the Bernoulli's law. The particle approaches the airflow from the top of the surface. Let's say the particle is flowing from the top of the surface. It should travel. It should be going straight, right? But the particle follows the curve of the wing and it goes down. So particles from here, it travels with the curve and it flows down. But usually if it's flowing from here, it should go straight. But that's not the case, and we will explain why. The particle approaches the airflow and it takes curves as shown in this diagram. But it doesn't go the straight. As shown in the examined curve, let's examine the curves closely, the particles on this diagram. So here, let's say this is our airflow, this is our particle. The curve there should be feeling more pressure at the top here. It should have high pressure and it should have here low pressure. To generate the case, to flow, the particle can only flow with the curve if it feels high pressure on the top and low pressure at the bottom. This will supply the centrifugal force. So this will create the centrifugal force. Which is why the flow is always attached to the foil with the wing. The effect is known as the Conda effect. The flow gets curved also at the bottom of the wing. The same thing happens at the top of the wing, but this time the curve will get more curved. The curve will get more than the bottom because of the pressure difference, more curved surface. In short, the introduction of the airflow makes the flow curved and deflected. This flow is exactly what causes the lift. So if we have the aeroplane, when the air is flowing from the top and from the bottom of the wing, the difference in the high pressure and the low pressure on the top and bottom of the wing creates lift.